Hi everyone, welcome back to our statistics class notes. Professor Sebastian, and we're in section 6.1 talking about probability distributions, and we just got done talking about a probability distribution for a continuous random variable, and you can see that we no longer can use tables or spike graphs. We have to use these probability density functions or a density curve, and the area under that probability density function over a range. This was an example of what's the probability of waiting between 0 and 2 minutes in this coffee shop. Okay, so the example we just got done going over on this page 79, we have to find the area under here. Now, and I talked about how you really can't do that because this is a curved function. Unless you have some calculus ability and know exactly what this function is, you can't do it. But there is one that we can do at our level, and that's called a uniform distribution. Okay, uniform distribution has a flat top, so the area under that curve is always just the area of a rectangle, which is an easy thing to compute. So for example, a bus arrives at a certain stop every 12 minutes. The graph on the next page, so you can kind of look down there, start to see it, this box. The graph on the next page shows the probability distribution for the continuous random variable x equals the wait time before the bus arrives. So the random variable is x, which is the wait time before the bus arrives. This is an example of a uniform distribution. So the bus arrives at a certain stop every 12 minutes. That is a distribution in which every possibility for the random variable x is equally likely. So if you got there just after the bus left, you'd have to wait about 12 minutes. If you got there right before the bus was leaving, you'd wait like 0 minutes. And then every possibility in between 0 and 12 minutes is equally likely to happen. That's our thought process behind this random distribution, which is just that every possibility of waiting time is equal, so you have a flat top. So the area over a range anywhere is just the area of a rectangle. And notice that the area inside the whole rectangle, which adds up, because all probabilities together, it has to sum up to 1. So since the waiting times are between 0 and 12 minutes, then the height of this box has to be 1/12, right? Because 12 times 1/12 gives us an area of 1 inside this entire rectangle. So we want to use this distribution to find the probability of a wait time between 4 and 10 minutes. So we want to know what probability we'd have to wait between 4 and 10 minutes for this bus. So what you need to do is you need to find the area under the curve between x equals 4 and x equals 10. So I've highlighted it here in red. Okay, the area between 4 and 10, which again, just the area of a rectangle. The height is still 1/12 because that's the height of the entire box. So the area is just a rectangle, so we can find the area of it by computing length times width, or base times height, whatever you want to think of it as. So the probability that x is between 4 and 10 is the base of this shaded in rectangle, which is the length of 6. Okay, times the height of the rectangle, which is 1/12. So 6 times 1/12 is 1/2, or 50%. It's about a 50% chance of waiting between 4 and 10 minutes. Now, suppose an instructor designs lessons so that the class lengths are uniformly distributed between 72 and 77 minutes. That is, any time between 72 minutes and 77 minutes is possible, and all the possible values are equally likely. If we let x be the random variable representing the length of the class, then the random variable x has a distribution that can be graphed as shown on the next page, right? So similar to that, it's a uniform distribution, so x can be anywhere from 72 minutes to 77 minutes. So the length of the entire rectangle is 5 minutes, which means the height of it has to be 1/5. So the sum under the whole rectangle, the whole 72 to 77 minutes, has to sum up to be 1. Right? Base is 5 times height is 1/5. Okay, so is the length of the class a continuous or a discrete random variable? It's certainly continuous. It's over a range. We can't measure. We have to measure that. We cannot count all the possible times the length the class will take. Can a probability distribution or a table be created for this random variable? No, we can't. We can't create a table. Instead, we have to use this uniform distribution. So a table can't be created because we cannot list all the values. And what is the total area under this curve? We just talked about it. It's 1. So now if I want to determine the probability that the class runs over 75.5 minutes, in other words, you'd be getting out of class 30 seconds or longer late, right, for a 75-minute class, I'm looking at what's the probability that x is greater than 75.5. So I put a line here at 75.5, and that means it's going to be anything between 75.5 and 77 minutes long. So I just find the area of that rectangle, which again, the area of the base, or the length of the base is 1.5, so 1.5 times the height, which is 1/5 or 0.2. So that comes out to be 0.3 or 30%.